So in this video, we're going to be talking about how do we factor the difference of two perfect squares binomials. So last class in the discovery, we noticed that we can factor the difference of two perfect squares, sort of like the way that we would factor a trinomial. The first thing that we would do is basically this is a binomial that has a degree of 2. So what we can do is that we can, what we like to call, write the polynomial in standard form by filling in for the one thing that's missing. So here the x is missing, right? We have the constant, we have the x squared, so the x would be missing in the middle, and we can write a 0x to do that. So it'd be plus 0x minus 9. So now we can basically factor this the same way that we did before. And this only really works for the difference of two perfect squares, so it wouldn't work for the sum of two perfect squares because you need to get the 0 here, and the only way that you're going to get the 0 here is by having the same exact thing but with different signs. All right, so 4x squared, again, it's a perfect square, so I can make it into 2x times 2x. And so is 9. 9 is a perfect square. I can write this into 3 and 3. And so again, I have the same exact two things. My goal is that when I combine the inner and the outer, it becomes a 0. So obviously when I multiply 3 and 2x, I'm going to get 6x. And when you multiply 2x and 3, you're going to get 6x again. And so my only concern is to get two different signs. So one needs to be plus and the other needs to be minus. And then that will make sure that it cancels out. And so I have two factors. And my factors here are 2x plus 3 and 2x minus 9. Minus 3, sorry. Okay. Now, let's go ahead and do the second example here. 25 is a perfect square and 16x squared is a perfect square, and it's the difference of two perfect squares. So I know I can factor this into something pretty much like this. But first of all, we need to write it correctly. The first thing that's kind of wrong with this is that my x squared is at the end. So when we factor, our x's need to be in the front. So we're going to rewrite this as negative x squared plus 25. And then what we're going to do is that we're going to go ahead and, just for the sake of it, go ahead and put that 0 in so that we remember what we're trying to do. If you remember, we don't want our first term to be a negative number, so we're going to factor this out. And then now we can factor this as a difference of two perfect squares. So 16x squared is going to be 4x and 4x. 25 is going to be 5 and 5. And then again, I need a plus and a minus for them to cancel out. So I have two factors, and the factors are 4x plus 5 and 4x minus 5. And then my last example is just something a little bit more algebraic. So remember, just like before, if we have a greatest common factor, we want to pull that out. And if you notice, both terms here are being multiplied by y. So we're going to take this out by distributing it out. So we have y times x squared minus 16. And then you should notice this is the difference of two perfect squares. So again, that's going to factor x and x, 4 and 4, and we're going to have a positive and a negative here. So in this case, there are three factors, and my factors are y, x plus 4, and x minus 4. Okay. So this is the end of this video, and I hope that you found this helpful for factoring the difference of two perfect squares. This topic comes up a lot, and it's just nice, first of all, to be able to know that it's the difference of two perfect squares. So if I put the sum, this would actually, other than taking out the y, it would be prime. And so we couldn't do anything further with it, but the difference, we can factor it. Okay, so this is the end of this video.